Okay, it should be noted that I'm making this example up, which means that the numbers might be really nasty or this mountain might be impossibly tall.
Oh.
Cool? So what we're going to do is we're going to pretend that there's a flat plain and then a big mountain. I would like to know how high above the plain the mountain is, right? Okay. So I'm going to do this. I'm going to have two people go out and stand in the plain a ways apart. For kicks, let's say they're 10 kilometers apart. Okay? And then I'm going to have them look up at the mountain. And get an angle here, off level, right? So what's it look like this first guy's doing?
A 30.
Cool, we'll call that a 30-degree angle, and we'll call this one a 60-degree angle, just so everything's easy. You guys see that?
Yeah, why'd you do kilometers too?
Because I like kilometers.
Yeah, but we're in the United States.
Well, the mountain doesn't have to be the United States. What if the mountain's in Kenya?
Sorry. Go ahead, sorry. Stupid.
Can you believe that?
Sure, fine.
No, my question was stupid, that's what I'm saying.
No, it's cool. We'll put the mountain on another planet. That'll make things easier. I guess it's on the moon. Whatever. Anyway, point is this. So, how do I start this to figure out how high this mountain is?
You draw a straight line from the plain to the top of the mountain.
Okay, cool. So, draw this line down, right? That's a 90-degree angle. Okay. What else do I know in one of these triangles, right? There's two triangles.
You know
What
the-
configurations am I in for them?
You know the side length of the one that isn't a right triangle with a 30-degree angle?
I know the side length of, oh yeah, I know this thing,
Yeah.
right?
Well, you know all the angles actually now. If you know that's a 90.
Oh!
It's true, you do.
So right now I'm in angle, side, and then do I know this angle?
Yeah, it's
Yeah,
120.
and so you do the 60 angle
Then that other
first.
one is 30? No, yes.
And then the other one up here is,
60 plus 90, 50, yeah, 30.
Alright, so the triangles will go up there.
30 degrees there?
Yeah.
Cool. So I'm now in, this triangle is a angle, side, angle triangle, right?
It's also 30 up there.
Yeah, and I guess I know one more angle, right?
And then you know the total angle for the, make it one big triangle.
What?
Ah.
So 30, 30.
Nah.
Okay, what else can I do here?
You can find the other side of the one that's a right triangle.
I can-
Angle, I mean.
Oh, you mean I can find this side?
Yeah,
Yeah, that's probably a good idea.
but, no, I mean, the other angle, it's a 30-degree.
Oh, this other angle.
Yeah.
This here? So that's also a 30-degree angle.
Yeah, so I say, yeah.
Yeah. I know it's not to scale, right?
Heavily.
Heavily not to scale. Okay, so let me see. Which thing's going to help me the most? I want to know this height, right? You guys see that? So that height there, I think I'm going to call the, suggestively, the opposite side, right? What is it opposite to?
The 60. And
The
the
60,
other one.
right? So what do I know that relates opposites and other stuff in a right triangle?
Tangent,
I know tangent, and I also know
or sine.
sine, right? You guys see that? So I have two kind of options. So I can think about tangent of 60 or sine of 60. Okay, so that would clue me in that one of these two sides is going to be my next target. Right, I'm working backwards from the conclusion. Which of those two is in a triangle I know stuff about? Yeah, the hypotenuse is. You guys see that?
Yeah.
So
Because
you
the
do sine.
hypotenuse is in this triangle.
Yeah, so you do sine.
You guys see that? So how am I going to find the hypotenuse? How am I going to find this purple tick size?
With sine.
Yeah, I want to solve the other triangle for that side, which means I need to do
Law of sine.
probably law of sines.
Law of cosines would be better, I
Ah, law of cosines is usually better. Do I have law of cosines available to me? Why not?
think. No, We need a side.
Because you only have one.
Because I have one side, right? To run law of cosines, I need two sides.
Okay,
Crap.
so let's do law signs.
So we have to do law of sine.
It's really easy.
Okay, so I'm going to call that side HY, even though it's not the hypotenuse of the triangle I'm going to work with right now. You guys see that? So what do I know about this side HY?
You know that it is
Sine of
opposite of the 90.
Sine of 30
So I know that sine of 30
over HY.
over HY is what?
Sine of 30.
Sine of 30 over 10. Oh, that's really convenient, right?
Yeah.
Because that tells me that the hypotenuse is
10.
10.
It's isosceles, baby.
Do you guys see that? I maybe could have noticed that it was an isosceles triangle and the two angles did the same.
Yeah.
Oh, whoops. My bad. So the hypotenuse is 10. So, how do you get the opposite out of that?
Sine of 60 equals opposite over
Why'd
10.
you put the line
Oh, just,
What about the thing?
through? I mean, you know, I was just wondering if it was like.
I was just replacing the idea of HY
You don't
with
know what
10.
the other side of it is.
Alright, let's use that law of cosines thing.
No.
I don't need that. I don't need to go overkill. Because I have a right triangle here.
Yeah, so it's just
Okay.
sine of,
So sine of 60 is 10,
over x.
whoops,
So it's hypotenuse. It's opposite over 10.
yeah,
X over 10.
it'll be the opposite side over 10. And so the opposite side is
10 times sine
10 times sine
of 60.
of 60. What's sine of 60?
Oh. So that should be.
So they're 1/2 or
3
square root of 3 over 2.
Oh, wait, I think I'm reading.
3 over 2.
And it's root 3 over 2. So this is 10 root 3 over 2, which is 5 root 3. And what are the units on that? Oh, I circled that like I was done.
It's 5 root 3 kilometers high.
Yeah, so
Tall.
the mountain is 5 root 3 kilometers tall.
Plus the person. Yeah.
Ah,
Plus the
Plus
person.
5.5.
Plus height.
Ish. You guys all good with that?
Yeah.
So yeah, we'd add the frickin', in terms of a kilometer, a person?
2 meters.
2 meters, so 1/500th. So we add 0.002
I love
to whatever the answer was.
It's like 8.7
Aren't you the one saying to
kilometers
convert it to miles?
Is that-
Yeah, so
That's what I'm saying.
8.7 kilometers tall. Does that jive with our picture? Probably not, but our picture's horrible, right?
Yeah.
You guys see that? Do you guys recognize that this technique could be used kind of in general for this stuff? Yeah.
I asked them about it. That's when I found out.
Oh yeah, this is actually a technique that's used.
It says it's a pain in the ass, like every 15 or 5 to 15 feet.
Yep. Yeah, this takes forever.
It's just eyeball.
If you're doing a good job, eyeball 'em? Oh no no no.
Like. Yeah, you use that.
Yeah, you use a scope or if you really want to do this for real and get good numbers, which sometimes they do, you put a reflector at the top and you use laser to get your angles. And you can get really decent measurements that way. In fact, there
Has to
are,
hike up to the top though.
yeah, somebody has to go to the top to put the reflector up there. But that often gets done actually. There's a bunch of mountains that have little things at the top and current measurements that you can go on the internet and see the current height of the mountain. Because they grow.
Yeah,
Shrink.
don't they grow like an inch every year or something like that?
I thought they grew to like the rate of your fingernails or.
It depends on the mountain.
Oh, okay.
Some of them shrink because they're eroding, some grow because they're being upthrust, some grow because they're volcanoes. Yeah.
Oh, the volcanoes, yeah, that makes sense.
So, yeah, there's a variety of things for this, and some of them are interesting. So we have little laser reflectors on lots of mountains. So if you go mountaineering, you'll oftentimes find these like little posts with a weird thing on it. up like the
And
top
it's
of.
catching the.
Yeah, they're just watching a laser from down in the valley.
Yeah, my brother just did fine, I can't catch that deep, they do that.
Oh yeah, and in reservoirs, they're super careful with this stuff. Well, they're supposed to be. All right, cool.